So this is a diagram of the AXI to OCP converter, and out of which you have already learned the AXI write front end part implementation. Now you will go through the AXI read front end part implementation, which is comparatively less complex than the write front end. This was the diagram of the AXI write front end, and in the right portion you have to save the address and incoming write data into two separate FIFOs, as we have two channels in the write packet where there is an address channel and a data channel. But in the read portion, this interconnect will be getting only the read address which it need to route to the OCP client. Thus, in the read front-end FIFO or in the read front-end module, you will be only having this portion where it stores the read address, and it will not have the complex write data storage part. So this is a diagram of the AXI read front-end. As you can see that the input read address should be combined with the ID and length and pushed to the FIFO and popped out accordingly whenever there is no hold incoming. Now we will go through the coding part. So this is almost same as the write front end, except there is no write input, there is no write data portion and data FIFO present. So you can see AXI read front end with input clock reset and read address dot slave type address interface, and then input hold in, and its output will be AXI read packet valid and an AXI address packet of type which is named as AXI read packet. And these are the internal signals, and this is a FIFO instantiation which is exactly same as that of the AXI write front end module which you have already seen. So its name is AXI address FIFO, and these are the write and read enabled signals and the write data read data signals. And the address FIFO or write enabled is equal to whenever there is a valid packet available in the address interface and a ready is there in the address interface, and its write data is input data to this FIFO, and write data dot id is equal to address interface dot id dot length is equal to address interface dot length, and write data dot addr is equal to the address interface read address interface dot addr, and the address interface dot ready is equal to whenever this FIFO is not full. So you can see that this is a full that is coming out of full signal coming out of this FIFO, and again this is read out. This FIFO is read out whenever we have a valid packet available and there is no input holding, and the packet is valid whenever the FIFO is not empty. So there is only one address FIFO, so whenever there is an entry in this FIFO, the packet is available and it's valid, and the output packet dot id length and address is appropriately driven out from the output of this FIFO, which is addr FIFO or data. So it's quite simple compared to the write front end implementation.